Sir Narasimha sir, good morning. నేను ఆన్ చేస్తాను. మీరు దాంట్లో కూడా వస్తుందప్ప. మీరు దాంట్లో కూడా వస్తుంది.
సార్ గుడ్ మార్నింగ్.
సార్ గుడ్ మార్నింగ్ సార్.
సార్ గుడ్ మార్నింగ్. హౌ ఆర్ యూ?
ఫైన్ సార్. Sir, good morning, sir. Sir, good morning. How are you? So, good morning to all of you. I welcome you all for the 5th day of the Faculty Development Program of the first session.
Sir, YouTube on, sir. YouTube on, sir.
So today we have with us Dr. Narasimha Sanke, Professor of Mechanical Engineering, Usmania University, Hyderabad. So before handovering the session to the Professor Narasimha sir, so let me introduce. So Dr. Narasimha Sanke is a professor, Department of Mechanical Engineering, University College of Engineering, Usmania University, Hyderabad. So sir graduated and masters and also PhD from the same university. So the areas of interest are biomass, new and renewable energy sources, heat transfer, applied thermodynamics, turbo machinery, thermal engineering, computer programming in C and C++, software development. So RD, BMS, web technologies, and microprocessor and its applications. So in one word, we can say sir is a multi-talented person, because sir joined in the Usmania University as assistant professor in the year 2001 to 2014, and today sir is a professor from 2017 to till date. Sir is having the research and industrial experience. Worked as a programmer in Telesys Technology Private Limited, Hyderabad, from 1998 to 1999, and then worked as a software engineer, CITP Technology for Transformation, Hyderabad and Bangalore. So sir published 30 papers in international and in journals and conferences. So and guided 55 both BTech and MTech students. Sir is having the 9 fellowships, professional bodies, like ISTE, SCSI, ISHMT, NSF, MFP, ISTAM, OGA, SAEI India, Spain, USA. So Sir also visited the various countries, Greece, Spain, China, USA and Canada, and participated in 11 workshops. And Sir is also a actively doing the social activities in the Usmania University. So and participated in 13 workshops also. And the training is also provided at a international training workshop on technology and utilization of biomass gasification in China. So Sir arranged guest lectures also, 12 guest lectures has given. He is also an organizing member, already said. Social activities is also organized. And he has 3 awards to his account. So he recognized as a top 100 scientists in 2009, International Biographical Center, Cambridge, England, and 2000 outstanding scientists in 2008 and 2009, International Biographical Center, Cambridge, England, and received Best Paper Award for computational analysis of advanced biomass downdraft gasifier in the international conference at Las Vegas, USA. So, Sir is also an administrator, good administrator. So, in charge of timetables, officer in charge for conducting MTech main examinations, department convener, officer in charge, computer laboratory, and member equip department convener for ME MTech admissions, director, Center for Creative Technologies, coordinator and assistant chief superintendent for main exams, director for Center for Energy Technology, faculty advisor in SAE India, collegiate club, student advisor in the Usmania University, website in charge and faculty advisor, ME Turbo Machinery course in the Department of Mechanical Engineering, Usmania University, departmental committee member and also board of studies member, in charge for college autonomous UCE, Usmania University, and also a member board of studies in mechanical engineering, Malad Engineering College, Hyderabad, assistant controller of examinations, professional one, Usmania University, departmental research committee member in the same Usmania University. So, Sir held many positions in the Usmania University, and he is in one word, a multi-talented person, both software and the mechanical engineering field, and also electronics also. So, thank you, Sir. So, with this, I welcome you all. I welcome Sir for the 2-week faculty development program on renewable energy interventions in industry, domestic, and commercial applications. So, over to you, Sir.
Yeah, thank you, sir, for a nice introduction. I think you are taken from that is website.
Yeah, sir.
It is not updated. It's a long back
Yeah.
pending with some other assignments now.
It is the time to update, sir. Please.
So I forgot to send them for my IT people, so to update it because of the COVID pandemic. Maybe okay. I'm going to update it. So thank you for nice introduction, and I'm really congratulating for entire Rajiv Gandhi Memorial College of Engineering and Technology, Nandyala management, and especially for the Department of Mechanical Engineering conducting for this 2 weeks faculty development program. In that, the pioneers is our coordinator, Dr. Siddha Reddy, and head of the department, Dr. Tirupati Reddy garu, and the principal, Jayachandra. I think there are the many people. I know how exactly and what are the pains which is required in order to make this program conduct. It's not so easy task. But your college is doing really as a wonderful job at this particular juncture, even in a COVID pandemic. So instead of going for offline mode, even online, you are pulled the resource persons from various places across the country. It's really amazing. And I believe that all the participants are going to take something or other at the end of this particular faculty development program. And I hope that they are going to implement at least something, at least they are going nutshell to their own students in their colleges after they're going back. Yeah. Yes. So you said, sir, just like me, a multi-talented. Yes, I was worked in IT prior to joining in the teaching field. Yes, so I worked in Bangalore, Hyderabad, in USA for different projects. Then I back to the India and I've joined in the Usmania University as assistant professor. Then I moved to associate and then the professor, and of course there are many things that is there in the website. And recently I gave a training for 80 of my college students, that is Internet of Things. So now the NASCAM is conducting on 23rd for them entrance examination and final examination in order to give certificates from them so that they can use in their own career. That is the recent thing which I have not updated, sir, in that. Okay. Thank you, sir. So yeah, good morning to everyone. Really, it is a great opportunity for me. I think right now there are, including me, 41 participants I could able to see in this participants list.
Some of the participants are in YouTube also, sir.
Okay, okay. Oh, very good, sir. Thank you. Thank you so much. Here, sir, first, before starting my presentation, I'm going to post a few questions on the mentimeter.com. And I'm going to share a code to you. So please respond, and after that we will start. It will take just few seconds only for your response. It won't take much time. Whatever it is there, please you can use your mobile phone or your laptop, whatever it will be there. You can just type the code which I'm going to share from chat box. Okay, or if you are unable to hear, please I will tell even the number so that the result progress also we can able to see. Then once it is finished, yes, then we will start into our presentation, sir. So, sir, can I share now?
Yeah, you can share, sir.
Oh, one second. Okay. One second. Yeah. Sir, you just please type. I think, sir, can you able to see this PPT, sir?
Sir, no, sir, no, sir. It appear in green color, sir.
Appeal green color.
Sir, now it is visible, sir.
It is visible, huh? Thank you, sir.
Now it is visible, sir.
Yeah. So I think, sir, you can able to see
What
something.
comes in
What
think
is
of the biomass?
what is comes in your mind when you think of biomass?
Sir, visible, sir, visible, sir.
Yeah. So, sir, please type this website. I am highlighting just in your mobile phone, maybe in your laptop, whatever it is there. Just type www.menti.com and it will ask you to enter the code. So you can enter this number, sir, 8947952. Yeah, good. It is started the response. Reusage. One participant is used word reusage. Anything. There are two options I gave there. You can type whatever word which is coming to your mind. Yeah, please quickly menti.com. You can type, then enter this code number, and it will ask you to enter the word which is coming to your mind. Even it is wrong, you need not worry. Please, you can enter it. Natural, very good. Quickly, just only in few seconds, sir. Here there is nothing wrong and nothing right. Everything is normal only, sir. You can enter it. Whatever comes in your mind. All are correct answers only. Whatever you are thinking, just type it. Enough. Yes, for energy production, very good. Please do it quick. Don't think much. Whatever you are thinking, that is absolutely right. Sir, is it my voice is audible, sir?
Yes, sir.
Okay.
Sir, audible, sir. Audible, sir.
Yeah. Thank you, sir. Yes, see, please, all the participants, please do respond. All, whatever you are thinking, all answers are right only. Nothing wrong in it. Okay, I'll share another one. Yeah. Yeah. Yeah, I think the second one, same menti.com, just type 9542773. From where do we get biomass? Types are in mobile, your laptop or desktop system, wherever you are connected. Use even the people who are in Facebook, even YouTube also, you can use your mobiles and other things, and you can type just www.menti.com and use the code number is 9542773. The question is, from where do we get biomass? Plants and animals, good. Please do quickly respond. Whatever you are thinking, everything is right. That's what I want to be clear very much. Whatever you are feeling the answers, yes, absolutely it is correct. Just only you post it. The 44, I can able to see the participants. Only one person is responded. Okay, maybe quickly instead of wasting the time, I'll go to the next one. It is just, I think it is already there. Yes or no, I think it is easy for you. Yeah, I'm presenting now. Yes. Same again, Mentimeter. Menti.com, www.menti.com, and use the code number is 20 47, 57, 5. Biomass, is it harm to the nature or not? So here only the options is given to you. First option is yes, second option is no, and third option is no idea. I think everyone is going to respond for this. Wow, interesting. Maybe please, at this point, I can expect the more participants are going to respond it. 3 people are dead. 3 of them are responded very quickly. Please do respond others to here only, okay? I think you need not dig anything in your mind. Straight away you can give either yes or no idea. Okay, I'll share another one. Oh, then another person is gave very good equal. You can give it. I can able to see in offline. Right. Yeah. Same again, menti.com. Use the code number is 5708873. The question is biomass energy, is it a new technology? So the options is given for you, completely new technology. It is very old technology. I am new to this biomass energy. www.menti.com, menti.com, and use the code number is 5708873. That is the code number, 7-digit number. You select the option. It's very old technology. One person is said. Second person, third person, very good. 4, very good. 4 of them responded. Okay. Yeah. Quickly, I'll move to another question. But you can respond it very quickly, no problem. I can see even the offhand. Yeah. Yes. Same again, www.menti.com, and use the code number is 4953283. I'll repeat the code number 4953283. Is it biomass resources are limited? That is the question. There is answers are there, like you have to pick option either yes or no. I'm new to this topic. Code number I'll repeat. 4953283. www.menti.com and the code number is 4953283. Interesting. It is equal point now. 3 of them says same. Yes, it is limited. No, it is not limited. And I am new to this topic. 133. Yeah. So the last one I'll share and then we'll move. I think this can answer. I think everyone can able to answer this. Yeah, I'm presenting. Right. Same again, www.menti.com and the code number is 20 22 16 1. I'll repeat the code number 2022161. 2022161. Is biomass available in mines? That is the question. How many? Only one person is responded. Second person responded. Yeah, here I think expect more participants. 3, very good. Yeah, only 3 participants did. I think you can able to see the progress here. Only 3 of them out of 49. Of course, including me, 49. 4. Okay. So we'll stop. Very good. Over the 4 people did the participants is really very, very good. It is impressive. Oh, 5 people. Super. Very interesting. The participants among it. Very good. It is very easy. Even you can create your own regular classes too like this. You can immediately can give to your students this question in a fraction of a second. You will get the answers. Whether it is in online mode, in offline mode for your subject, you can do it even. Okay. Yeah. So we are going back now. Oh, very good. 6 them responded. Should I wait about a minute? 91 participants are there. Whoever is joined right now, please use www.menti.com and after that website, and it will ask you to enter the code number. The code number is 2022161. I'll repeat code number 2022161, and it is available to you. The question is it available, the biomass available in mines? So there is a first, second, third. Total 3 options are there. Yes, no, I'm new to this topic. So quickly respond it. I can see even offline. Yeah, you can respond it. All the participants, no problem. It is going to record here. Yeah. Yeah, I'm sharing my PPT. Yes, sir. Please give me the confirmation. Is it visible, my PPT?
Yes, sir.
Yeah. Thank you, sir. Yeah. So same thing. Whatever the program for you are here, the same slide I am just welcoming. Okay, a part of the organization team and as a resource person. Okay, online 2 weeks faculty development program on renewable energy, intervention in industry, commercial and domestic applications is really very good, fantastic topic. Yeah. So this is the thing. My topic is mentioned in the brochure is biomass energy. Okay, is that utilization of biomass energy for power generation, especially in rural India, especially in rural India. Yeah. So these are the things which we are going to cover in our lecture. Okay, like the introduction to biomass, then the components, transformation technologies, gasifier, gasification, biomass resources, biomass potential in India, and something which is required to keep in our mind. Okay, that you can take it to your place. Yeah. So after this presentation, even I will show a video of my experimental work. Okay, I'm going to show my video, and you can able to see how this biomass gasification is generated. Okay, and then of course we were produced the electricity power in my university in my center. Yeah. So the introduction to biomass. So I think you can able to see this is a small plant. It is getting growing, right? Yeah. Yes. Yeah. I'm making it down. Right. Thank you. So biomass is a scientific term for living matter, more especially an organic matter that has been derived from plants as a result of the photosynthesis conversion process, right? So the all these plants, whatever the plants is going to be plant, okay, so after some time it is going to become a tree. After some years is going to become a tree. So those plants are going to become, of course we know that the plants and the trees which is going to absorb or which is required a part of the photosynthesis, the carbon dioxide which is required for it in order to grow, and the trees are going to emit oxygen, and whatever we producing carbon dioxide that is utilized by the plant. Okay, I'm not talking about other end point of view like the automobile sector, the things and all that. Okay, that's not the thing for here at right now. We are talking about only the tree. Okay, so simple term for biomass, scientific term for living matters. Okay, more especially an organic matter that has been derived from plants. How? As a result of photosynthesis conversion process. Okay, so you can able to see the plant of this we will call it as the stem, right? And the flowers and leaves. Okay, these are the parts, the simple parts. I'll tell you. There are many. Okay, then so this plant is going to grow like this, and after some time it is going to become a big tree. So you have a stem, then the branches. Okay, again the branches, sub branches and sub branches. Then it's going to give, depending on the tree and plant, so it is going to give a crop based on, right, they're going to produce their own flowers, and then after some time it is going to give the crop, whatever crop is required. And after maybe during the year, during the particular seasons, especially in the December and sometimes all these trees, whatever the tree having these leaves, all these leaves are going to litter. It is going to fall down. Again, it is going to start the fresh yield is going to come. Okay, so it is a cyclic process. Every year, yes, the leaves are going to litter and it is going to fall down. Then again, the fresh leaves are going to get it up. That's how it is going to start its own life. Right. So the word biomass is also used to denote the products derived from living organisms, that what wood from trees, harvested grasses, plant parts and residues such as stems, leaves, as well as aquatic plants. Here pointer, yeah, you can able to see the pointer now. See the word biomass, okay, is to denote the product derived from living organism. What exactly wood we are going to get from the trees, and harvested grasses, then plant parts like leaves, flowers and stem, etc., and residues. Okay, residues such as stems and leaves, and as well as aquatic plants. All these things comes under word biomass. Yeah, you can able to see here some of the pictures over here. These are the wood from the trees. This is the harvested grass. Okay, and this is aquatic plants. That means the plants which is grow in water. It is going to grow in the water. Okay, I think you know that, right? We will call it as algae. Okay, if you store the water, maybe even in somewhere and sometime with the longer hours, so we could able to see bottom side the algae is going to get formed. That is very minute level. But if you take bigger places like maybe a river or maybe a tank or reservoirs, and we can able to see this. You will be having big, even small tanks beside the road. There is a small tank. Due to the rainy season, it is going to come. Okay. Sir, somebody is please unmute whoever is speaking. Somebody is speaking. So please mute yourself, sir. Yeah. Sorry. Yeah. So these are the some of the photographs which I am showing. Okay, aquatic plants will be looks like this. Okay, and this is the harvested grass, and I think we know this. Okay, wood logs. Yeah. So why biomass? Why biomass? Okay, biomass is a renewable energy source, and the energy generated through natural process It is evenly distributed. Just 1 second. Yeah, I'm sorry. Okay, thank you. Yeah, sorry. So the biomass is the renewable source and energy generated through natural process. It is more evenly distributed over the earth surfaces than fossil fuel energy sources, right? So the fossil fuels are like, I think you know it, the mines like a coal, petroleum products, so all these things comes under fossil. So that is available only in few courses, right? So oil wells will be somewhere like in seashores and other places. The reservoirs are available. You need to dig it up and take it out. Even the mine, like a coal mines, is available in the few places. So they have to dig and they have to take the coal mine. But what's happening? The coal, whatever it is there, coal or the petroleum, whatever the thing which is present in the resources under the ground, when we are digging and taking out from the ground, because no one knows that at what time the resources are going to get exhausted. That means it may not going to available. Maybe after 100 or 200 years, no one can say that whether the coal is available and these natural gas products are going to available or the petroleum products are going to available. No one knows that, right? And suppose if you want to form a coal, it will take some billions of years in order to form the coal. It's not like a day or two is going to form. It's very difficult, right? Yeah. Whereas, I think the plants which are going to grow just like that, not like another species of the trees. I'm talking about some of the plants and some of the trees which are going to grow just like that, maybe with a lesser period of time. Within 5 years, yes, it is going to grow, but those trees we cannot use for any other like purpose, like either it may be making any kind of the furniture. You cannot use that, or you cannot use that for something else. Even if you take out, even if you clean that place by cutting off something else, and those trees again it is going to regrow. Okay, those trees we cannot use for any other purpose, and it will not go like very bigger higher altitude too, very even the smaller height. Yeah, if you cut again it is going to grow. That we can able to see even sometimes the trees. Okay, is going to happen it. So is it provides what this why biomass is. It is going to provide the opportunity to be more energy self-sufficient and help in reducing global warming. That is another reason. What is the reason? First one is it is renewable energy sources, and it is going to available for entire the earth surface. And the second one is it provides the opportunity to be more energy self-sufficient and helps in reducing global warming. That's another reason. And the next one, it helps the farmers and foresters better manage waste material and provides rural job opportunity. How the farmers, okay, going to get the better managing of the waste material? Here I'll tell you, if you go, I don't know in the urban, but if you go to the rural places, okay, maybe even your college, Nandiala college, or even the outskirts somewhere, you can see the farmers every year, okay, maybe around July, June or July, depending on the monsoons. So they are going to make seeds and spread into the land, okay, the dry land. So, like example, like a tour, okay, a cotton, okay, and maybe other sources. So they are going to plant all those seeds are they are going to put into the earth soil, and they'll wait for the rain. When the rain will come, okay, sprinkle the water, and after some time it is going to yield, and then it is going to start those plants. The seeds are going to start yielding, and slowly the plant is going to come out. It is going to move little the higher, then it is going to give the crop in about maybe 2 to 3 months. So they are going to get the crop, right? After the crop, what happened? They are going to take the crops. Then what happened? The rest of things stack will be just throw it away, or they are going to leave it in the field itself only, because that is not going to reuse for any other purpose. Example, you can remember it like you have the groundnut shell, okay? Maybe you can have even a toad, or you can have a cotton. Example, I am telling, like there are many. These are available, right? Only particular the season it is going to give that particular the crop. Once the crop is over, what they are going to do? The rest of the material, crop is completed, completely they're taken out. The rest of thing, what happened? Just they will cut and they will throw it away. But that material can be used as the biomass resource. So here what happened, suppose you have your own industry, biomass setup plant, you have it, and you require to use only such kind of the resources in order to run. Then what happened, you need a people going to the farmers' places, collecting the entire material, okay, and storing in your place, storing your somewhere, right? You need a small kind of the go down so that you can able to store, and you can use whenever you want it. Okay, there are many people, and a lot of area is available, the crop field, and once the crop is completed, so you can mobilize some of the people, and you can go. Or if you directly tell to the farmer itself, okay, instead of hiring the people from outside, so the farmer, what they do it, once the crop is completed, yeah, so he's going to collect the entire the material, he will be preserve it. Then whenever is required, you can go and collect the material. By the time, you can give some kind of amount to them. So instead of throwing just like that and away, and they are going to firing it, something it up, instead of that, you can collect it and store it, so that we can pay some kind of amount to the farmers. Or maybe if you are engaged, some of the people continuously need to be collect from the entire the places. Yes, so then the opportunity is coming to the picture, job opportunity, right? Then the forester, yes, the forester also, instead of throwing just like that anything, the forest which is going to litter a lot of residues is like every year based on the seasonal, isn't it? So I think if you somebody has visited any forest, you can able to see it is not just like a plain ground. So a lot of the leaves, dried leaves, there are dead trees which are there sometimes, and many things. So that we can collect it. If you say to the forester, yes, I'm going to take all these kind of things, yes, then they are going to make, instead of throwing just like that away, they are going to arrange in one particular place, so we can take it up. Okay, so there what happened, ultimately some kind of job opportunities are going to get it. Then so the biomass is used continuously, as opposed to solar, wind, which are intermittent. Why we are telling it as an intermittent? Solar, what is the problem here? Solar is available only in the daytime, right? So sun is not going to available in the night time. Similarly, wind of course it is available for 24 by 7, but the density of the air will not be that much. Suppose if you are going to take during the midsummer, assuming that the temperature is somewhere around 48 and 49 degrees centigrade, 49 degrees centigrade, you might have seen even evening at the 6 o'clock or 7 o'clock, when you stand outside of your homes, okay, your house, if you look at the plant near your house, okay, in front of your house, those tree leaves are not going to litter. I think you might have seen this, right? Why? Because the density of the air is not sufficient. Don't think that air is not there. Air is there, but it is a diluted in the density. It is a diluted in the density. Okay, so that air, the kinetic energy of the air is not sufficient to floating off or disturbing of leaves. then we feel that there is no air circulation. Yeah, so I think you have seen this, right? In such a case, your wind turbine is not going to operate. It's not going to rotate, right? But whereas in this case, the biomass, yes, you have collected. So you have the storage system and you can make the process, whatever the biomass you are collected, then happily you can run your own plant. Happily you can run your own plant. Okay. Yeah. So these are the some of the reasons why the biomass is required to use. Right. So this is the biomass component or little bit of the somebody is good at is the chemistry. Yes, you can able to understand it. Of course, I am not a chemical engineer over here. Okay, but I can tell you, if you take any kind of the biomass, any species of the trees, you can able to see these three different components. So, like example, this is a plant cell. You can able to see a red, green and blue, three different. So these are three different components which are going to involved in the biomass. So what is there, you can able to see the color I've indicated over here. It is in the green color. The green color, it is called the cellulose. Green color, it is called the cellulose, and this is the chemical structure. You can able to see it. And next one, the red color, you can able to see, it is called the lignin. The structure will be looks like in this particular fashion, kind of the benzene shape is going to come, and these are the chemical formulas and as well as the what do you call the structure of the lignin. Okay, then the next one is the bluish color. The blue color, which is called it as hemicellulose. Okay, and it will be like this, the combinations of oxygen and hydrogen, which will be presenting like in a different of the structure, the chemical structure. You can able to see, you take wood any wood species. Okay, so you can find all these three: cellulose, lignin, hemicellulose. But the percentage of cellulose, the percentage of lignin, the percentage of hemicellulose are different. It is not the same percentage is available. Okay, no, it's not going to available the same percentage of cellulose, same percentage of lignin, and same percentage of hemicellulose. No, it will be different from plant to plant. Okay, what we can do with this particular the plant? Yes, so the solid, the whatever the wood piece something is there, with help of that we can able to produce the gas. We could able to produce liquid. So we the option is we have to choose whether should I generate the gas or should I generate the liquid. But my research, what we did is we have to chosen toward the gasification. Okay, toward the gasification. Yeah. So here you can able to see the lignin. Now, how much the percentage for the lignin? This is the red one. The red, it is mostly is an outer side of the wood, right? It will be vary 15 to 25%. So here you can see the complex organic structure, very high energy content structure, and difficulty to do compare. It's very difficult for the decomposing. Is required the higher in the temperature in order to decompose. That is very hard structure. It is just like example point of view. You can just imagine like the human beings. Okay, we are standing and moving everything. We are having this kind of the structure. Who are the supporting for this? Your backbone, right? Your bones are supporting, isn't it? So like in order to make a tree stem and it will need to grow like a structure. So who are going to help? Lignin is going to help. That is hard component. Yeah. Okay. Yes, that is a irregular polymer. Yeah. And the next one is the hemicellulose. You can able to see the hemicellulose. The percentage will be vary from 23 to 32%. So here the polymers of 5 to 6 carbons of sugar which will be there, but it is easy to compose. It is going to easy to compose. Say simply easy, it is going to decompose. Okay. whenever we are making any kind of the process, right? Uh, Yeah, and the third one is the cellulose. Cellulose percentage will be vary from 38 to 50%. Okay, so is then the polymer of the glucose, and it's very good for the biochemical reaction point of view, and the feedstock and concrete, and it is very soft. It is very soft, like in jellish. This one. So these three things are going to present in the any wood tissues. Okay, fine. Yeah, so here you can able to see some of the things I'm going to say. So strongly discouraging the deforestation and go green. So I'm not telling that you go and cut the trees. That is absolutely is wrong. It is not required to harm the forest. Whoever is going to do that, please try to stop, because plenty of biomass resources are available without harming a forest, without harming trees. Need not. You instead of that, what happened? You plant, make a lot of plantation, then automatically your resource is going to get increases. Okay, I'll tell you later the list what are the places and how from where we are going to get the biomass. I'll tell you. Okay, yeah. So these are the things like that we can able to see in now. I think little we have changed the people. They were not making any harm to the forest, and they are starting growing up the forest right now. They were started at the good initiation from the citizens point of view. But previously, you can just look at back for 10 years back or plus old. You see most of the deforestation is occurred. Okay, right. So here you can see this is the residues and cut off chunks when they are cutting up the trees and something. So the chunks which is going to come out and then collected and placed like this. Okay, and you can able to see these are the same again the cutting of these the branches. Okay, and this is some of the tree. It has become a virus inside the center point. It became a halo. So this is the dead tree. This such kind of the trees we have to take out. Such kind of trees you have to immediately separate and take it out completely and close that man, so that this can be used evenly. Okay, but the healthy things and it is good one, you need not. Okay, you should not do at any point of the time. So I'm strongly discouraging for the deforestation. Okay, so you can able to see here there are many trees. Okay, the leaves during the dry season like December and April. If you are moving to like a thick forest or somewhere where a lot of trees will be there, something like that, you can, I think if you are going on that, you can able to see these are the lot of residues which are fall on it. It's very heavy. This we can able to collect it, and once you collect this, yes, you can preserve it and you can make use this as a resource, biomass resources. Okay, for the fuel point of view, we can use this straight away without any problem. Okay, just make only little more the process is required. That's it. Yeah, you can able to see here also, right? So these are all the red color. Okay, you can able to see during the December. Okay, all these leaves, whatever the leaves are there, that is going later down. Okay, it will be become a dry immediately, so that you can collect it. Okay, yeah, it is good. So that means managing the forest in the better way. Okay, by collecting and taking out all those particular residues and collecting, that means you are cleaning the forest every day. Okay, that means only the residues and other things, not the rest of the things, right? Yeah, so you can able to see here also. So earlier the deforestation is occurred, again they were started the plantation, so it is growing. Now it is becoming a lot of greenery in this particular places. So then after December time, yes, so all these leaves are going to litter at the ground. Yes, we can able to collect it straight away. Okay, sometimes the grass also will be there sometime, right? The grass also going to become the dead after the season is completed, so you can collect it. Then again when monsoons come, then again start the rains and all that, again it is going to start the regrowing. Okay, so grass will going to come. So here also you can able to see a similar way, right? Yeah. Yeah, so biomass has zero impact on the greenhouse effect. We'll see how it is. Okay, you can able to see this. So these are the trees, right? Suppose the dead trees, assuming that dead plants or dead trees, something, whatever it is there. So that you are collecting from the forests, okay, and making the transportation and sending into the factory where the power generation or gasification or something is going to occur as a resource of this waste material from the forest. They'll be collecting over here and using it. So this industry, what is the outlet which is coming out apart of the process? So the emissions like the carbon dioxide, which is going to release. So this carbon dioxide and sun energy, photosynthesis, which is required in order to grow the trees. That means whatever emission which is coming out from the collected material, the same amount is sending back to the environment, and that will be utilizing back and regrowing of these trees or plants. Okay, so that means we are not adding anything, we are not taking anything from the atmosphere. So unlike a coal, what happened, you are digging a coal from the mines, right, and you are using for the power generation or some other purpose, the combustion is taking place and a lot of emission which is going to come and spreading in the environment. But when you collect that, really whatever we are transferring into the atmosphere, the carbon dioxide and other things, or they are going to use in the limited period within a 1 month with those particular emissions, is it going to form again a carbon like a coal? No. That means simply we are depositing. Even when you take the petroleum product, okay, the gasoline, all your automobile vehicles are running, right, on the roads and different places, and lot of emission which is going to coming out uncarboned the fuel mixture also which is coming out apart of the carbon dioxide, monoxide and other parameters, and those simply just dumping on the environment. But when it is dumping, when you suppose if you collect that, is it going to form again your petroleum, oil well, all gases, or is it going to form with that? The fossil fuels are going to form with that? No, right? It will take a longer and years in order to form, with depending on the earth crusts and the earth plates and all those things. Yeah. Hello. Yes, please. Sir, anything want to ask?
Chandrasekhar Meda. Sir, if you want to interact with the professor. Okay, sir.
Yeah, thank you. Thank you. Yeah, so here you can see now the solid biomass processing facility may also generate heat and electric power. Heat and electric power. That means if you want only the heat, yes, you can able to generate the heat. If you want the electricity generation, you can able to generate even electrical power by using solid biomass processing. That means what happened, the leaves, whatever you are collecting from the forest, or whatever the energy crafts after completing of the craft, whatever you are collected from the farmers, so you can make into a solid biomass for that, and then you can reuse. So what we will call it, that the solid making of solid biomass is nothing but those leaves are not into the solid, right? So we will make into the crush, we'll make into the powder, then we will use adhesive something in it, then we will make briquettes. We will make briquettes simply. You can make the briquettes. If it's not possible to make the briquette, you can make it as a pellets. So these briquettes or maybe the pellets in the solid, we'll call it as a solid biomass, and those we can use as a fuel for the biomass. Okay, later I will tell you how the gasification is going to take place. Yeah. So during the conversion process of such combustion, biomass releases its energy, often in the form of heat, and the carbon is reoxidized to the carbon dioxide to replace that which was absorbed while the plant was growing. Okay, so biomass absorbs carbon dioxide during the growth and emits during the combustion. So therefore, it is a recycled atmospheric carbon and does not add to the greenhouse effect. That is the reason we will say the biomass has zero impact on greenhouse effect. Yeah, you can able to see here one more. Okay, so let us say tree plantations. Okay, something you have taken the branch in order to make the wood products. Okay, maybe like a furniture or maybe the cotton box or something you can able to manufacture with that. So during this particular process, what happened? You will be getting sawdust, right? When you are cutting off that dead trees or something, you are going, or when you are taking that logs and sending into furniture industries. So then the furniture industry people, they are going to cut it, right, by using their saw. During the operation, so we will be getting a sawdust, right? Though this sawdust can be used as a resource, okay, by making the briquettes. So those briquettes will be sending into the power plant, biomass power plant. Yes, the power is going to produce, and then apart of it, the carbon monoxide dioxide, which is going to come. So this carbon dioxide is reutilizing. So that means whatever it is producing, it will be reutilizing. So it is not dumping on just like that petroleum products or maybe the coal products. Okay, it is reutilizing. That's the reason we will say it is having zero impact. It has a zero impact. So there is a climate change also which is going to come. So you can see that's what everything we are telling that. You can able to see little tiny ants with a plantation. So earlier it will be like this. Most of the places in the country, even many remote places, many villages also, even if they available, they could able to see a tree a little far. Immediately they are going to sell that, and the people will come, they will cut and they will take that. Then the moment if you take out at that plant from that place, if you see what is going to happen, it looks like a desert. So that yields to climate change. So when there is no plantation, when there is no trees, how can you expect the monsoon are going to come to your place and getting the rains? Okay, if you want get the rains, what happen? It is required the greenery in order to attract the clouds. Okay, that is the important. But the people are doing like that. So now slowly they change it and making into the greenery. Then it is ultimately deals with a lot of rainies and all. Okay, yeah, so you can able to see if the greenery is there, the clouds are going to get attract so towards at this place. That means why? Because the density of air of very pleasant, very high, and the temperature even is not that much. The atmospheric temperature at this particular place, so it will slowly incline, attracting the cloud. So this thick cloud will be attracted, and it will going to become the downpour in this. That is going to help when we will making the plantation and the forests. Yeah, so it has a long been to understood that the plants are able to mitigate the forces of climate change by absorbing carbon dioxide from the air. However, there is a new study that is added another dimension to the role played by plant in curbing global warming by showing that they also emit gases that assist in cloud formation and atmospheric cooling. So that is the main point. A new study is discovered this. Okay, a new discover, it is going to discover what is that? It is going to emit the gases that assist in cloud formation and atmospheric cooling. Okay, when we are making the plantation. Yeah, so that's it. Then I am moving now to the biomass transformation technologies. Okay, here we can able to see there are the chart I am showing here. Like this is the biomass. Okay, direct combustion. When you take the biomass with direct combustion, then you can go for just heat generation, or you can able to generate even the power. If it is the direct combustion, you can have these two product, heat and or power generation. We can go straight away. But if you go for the biomass for thermochemical transformation, okay, there is another process. When you take the thermochemical, this is nothing but suppose you are taking a, let's say, a wood stick and something, and you are igniting. You are igniting. Then what happened? You are getting the heat at the same time you are getting the light also, right? You are getting the light. The flame is going to give the light. Okay, example I am telling. That is comes under the direct combustion. Okay, so when you take the biomass for the thermochemical transformation, you will be getting 4 different processes which are required in here. Thermochemical for transformation. What is that? One is the gasification. Second one is the thermal cracking. Third one is the direct liquefaction, and the fourth one is low temperature gasification. So if I am aim for the gasification, that means I'll choose the biomass thermochemical transformation only for the gasification. Then what I'm going to get? I'm going to get the fuel gas. I can able to generate a gas straight away. That gas I can use as a fuel. That gas I can use as a fuel straight away in order to run my engine, or in order to I use for maybe cooking purpose, whatever the purpose you want, you can use it. So straight away fuel gas, and as well as you can get even the synthetic gas, whatever the gas you want, we can able to make by the gasification process. Okay, suppose if you are taking it up, thermal cracking and direct liquefaction. Thermal cracking, direct liquefaction process. Here you will be getting liquid fuel. You are going to get the liquid fuel. Okay, you can call it as maybe like a biodiesel. You can call it as a biodiesel. Okay, liquid fuel. You will be getting the liquid fuel instead of the gas. You will be getting the liquid fuel. Okay. Then if you are aimed to low temperature gasification, if you are aimed for your process under thermochemical transformation, so you will be getting hydrogen and the methane you can able to generate. Okay, when if you are aimed for the process in low temperature gasification, okay, you will be getting hydrogen, methane. That's methane is going to form. Okay, suppose if you don't want this, the direct combustion and thermochemical transformation, and you would like to go for only biochemical transformation. Okay, biomass, and the process you are chosen is the technology is the biochemical transformation. So here you will be getting 3 different, again the sub process. One is anaerobic digestion, then aerobic pyrolysis, and third one is the fermentation. Suppose if you are taking anaerobic digestion, okay, you will be getting the methane. Suppose if you are taking the aerobic pyrolysis, so you will be getting the compost. If you are taking as a fermentation, you will be getting the ethanol. So based on what is your aim, okay, what kind of end product which you are looking from the biomass, so what kind of end product would you like to have? Based on that, you select the technology process, whether you want to go for the direct combustion or thermochemical transformation or the biochemical transformation. So if you are selecting, there is no issue. If it is a direct combustion, straight away you can go it. But if you are looking for the thermochemical transformation and the biochemical transformation, then your aim, again the subcategory you have to take, whether you want into the gasification or thermal cracking, direct liquefaction or the low temperature. Okay, otherwise anaerobic, aerobic, and the fermentation. That is the aim you can take of based on your targeted end product, what purpose you are looking for it. Okay, yeah. So I think we can able to see these all things comes under the direct combustion. I think everyone knows this, right? Mostly in our villages and the remote places, still they are using like this, right? This is the most commonly. Suppose big function is happening in the remote places, okay, even the villages too. I don't know in the urban point of view, even the villages places. So they will take a 3 different, different rock, they will place it, and they'll place whatever they want to be prepared, and then they will use all the wood chips or wood logs, small wood sticks, they'll place inside and they will ignite it. This is comes under direct combustion only. But of course, there is a lot of pollution also there. A lot of pollution also there. This is the direct combustion. Okay, and this is also we can able to see, like maybe making it a hot water. Even in the villages, yes, we'll be doing like this, getting a hot water after some time, and then you will be using. But of course, the smoke and lot of carbon monoxide, which also is going to come. If you breathe that, I think if you breathe the carbon monoxide, what is going to happen, right? There is a health problems is going to come. Why? Because instead of the CO2, CO you are breathing. So in your body, oxygen is there. So that oxygen part of the oxygen will be taking into a monoxide. Okay, so it becomes the carbon monoxide. Then what happened? Your this human body is going to become deficiency of oxygen, deficiency of the oxygen. Okay, so then if you check the pulse meter and all that, your oxygen level is with not 90 to 98 and above, somewhere it will go to 70, something like that. Then that leads to another problem. Okay, this comes under. Similarly, even this, I think all these three we have seen. And then this is the little thing they made. It is called the chula. Okay, or they will take the clay, like the potter industries, how they are going to make the pot. So they will take that same kind of the clay, and they will making a stove, kind of the like a stove will be placing with a small opening area, and the top is another opening area. So here you can use your vessel, food vessel, whatever you want it, and with this opening place, then just insert it, and then that's it. What happened? Whatever the charcoal or something is depositing at this particular place, but whereas here it is only will be here. And the important thing for this chula is what I mean. You can take wherever you want it. You can transport it. Okay, the way you are carrying the stove, similar way you can carry this and place wherever you want it, and you collect that firewood material, and then you can able to make your own food. Okay, this is a little better than compared to these three, a little better. Okay, this is comes under the direct combustion. Okay, just now I've shown the previous my slide there for the direct combustion. Okay, yeah. This is the making of the biodiesel. Okay, what the biodiesel, how we are going to make a simple cyclic diagram I am showing over here. So this example everybody knows. So example I am taking. Okay, like there are many. This is called the sunflower, right? So through the photosynthesis, it is going to become like this, and this, or we can call it as even the oil crop, or you can call it as even energy crop. So better one is oil crop. So from the oil crop, we will be collecting these trees. So here the seeds will be there normally. So you will be taking the seeds, and then what happened? You are making the extraction from the seeds, and then you will be getting crude vegetable oil. When you extract from the seeds, that oil is the crude vegetable oil. So this crude vegetable you are storing in the container, then we are making it as a refining. Okay, that means whatever the sediments and all those things will be there, that is going to taken out. How we are making the refining? With certain temperature. Okay, with certain temperature. So at that particular temperature, it is going to refine, and then you will be getting like clear refined vegetable oil. You are getting refined vegetable oil you are getting. So then we can able to make this refined vegetable oil is the transferification. Okay, how we are going to make the transferification? The refined vegetable oil will be alcohol will be added to the refined vegetable oil. Okay, a percentage of alcohol will be added in it. So when it will be adding and making that process, so you will be getting the biodiesel, one product, and other one is you will be getting glycerol you are going to get. So one is a glycerol and other one is biodiesel you are getting. Suppose whatever the glycerol you are getting, so this you can use in the food industries, you can use even for the cosmetic industries, we can use it this straight away. And this biodiesel can be used for the vehicles in order to run the biodiesel. So okay, you can run your buses, your truck, your lorry, and okay, whatever the systems are available, the transportation or automobile sectors. So you can use then what it is going to produce when you are running these vehicles with the biodiesel, ultimately it is you are getting the carbon dioxide that is going to emit. So what is going to happen? This carbon dioxide is reutilizing with the sun photosynthesis and the carbon dioxide. Again, this oil crop is going to get through. That means it is a cyclic process. This is called biodiesel cycle. Biodiesel cycle. Okay, it comes under the third level. Okay, this one, biochemical transformation. Yeah, so now I'll go another point here. The same one we can able to look into the few points in the biodiesel point of view. So what happened? A biofuel represents the fuel that is obtained via biological process, either in controlled laboratory conditions or in biomass plants. So biomass plants usually produce the renewable biofuels through a process known as contemporary carbon fixation. Okay, contemporary carbon fixation. Unlike a natural carbon fixation, which involves thousands, possible millennia, like a thick of the creation of a coal. Okay, it will take longer year in order to formation of the coal. Okay, but today's method is the speed up of the biological process. So from the biological process, immediately we can able to produce it. So suppose you are taking the oil well and you are taking that oil, the crude oil, which is coming out from the oil well, then you require to send the crude oil for the refineries. In the refineries, they will start the temperature from somewhere around 50 degrees centigrade to it will go about even 400 degrees centigrade. So each of the temperature places some amount of the fluid will be separated, like the petrol, paraffins, petrol, naphtha, okay, the petrol, diesel, kerosene, like all these going to get. So once everything is finished and final product you are getting as a tar. Okay, that tar will be using of the laying of a road, that we know everyone, right? It's that the like for about similar way formation of the ground. But whereas in the biological process it's not like that. So very quickly you can make the fuel straight away by using the oil crops. Okay, so unlike the fossil fuels which releases the carbon back into the atmosphere, so most whatever the biofuels are there, that is completely eco-friendly and do not increase the carbon emission. Okay, as an important fact to note that not all biofuels have zero emissions. Okay, the biofuels created as biomass energy are two types. What are those things? One is the first generation biofuel and the second one is second generation biofuel. So what is the first generation biofuel is using the biomass resources such as corn starch, I think you know, and the sugar cane reduces. First generation biofuels are created as a result of fermentation of the sugar in these residues. What are that? Corn starch, corn. I think you know the maize, we'll call it as corn. Okay, makabutta. Starch, then or maybe sugar cane residues. So from there, by using the fermentation process, okay, so they made these biofuels generation. Okay, so the resulting the biofuels are alcohol based and can be used to make the electricity directly or can be added the gasoline straight away. So as an example of the first generation biofuel is what? Biodiesel and bioethanol. Biodiesel or bioethanol, these two things will be coming under first generation of the biofuel. Then what are the second generation of the biofuels? With biomass featuring mainly agricultural residues and the municipal waste. The process to create the second generation biofuels is a sticker like lignon cellulose of the biomass ingredients are common in the creation of this type of the biomass energy. So the sugar monomer of the polymer in the plant dry matter is used to create the fuel such as ethanol. So when we using the second generation, that is like a agricultural residues, so we can able to produce the bioethanol. This is comes under the second generation. Okay, so now I am moving to the gasifier, downdraft gasifier, gasification point of view. Okay, so why I'm calling the gasifier with the downdraft? Okay, so this is a gasifier, or you can simply you call it as a reactor at this, the same which we are used in our research. So this is a feed stack. Okay, that means whatever the bio mass which you are collected and made according to certain sizes, and that is just placing of inside. It is a placing. Okay, this is a reactor. We will call it up. It will be placing inside. So this is the temperature zone is somewhere 100 to 150 degrees centigrade. This is calling a drying zone. Okay, that means the wood, whatever the wood chip, something wood small cutted pieces about maybe 3 centimeter, 4 centimeter, 5 centimeter of chips, okay, or maybe the cutted of the wood with maybe like length about 4 meter, sorry, 2 or 3 inches. You can have it. Even similarly, even the diameter, if it is there or something like it. We will cut a small pieces and will be deposited inside, but it is not 100% moisture free. There is a moisture will be present in it, so that moisture it need to be taken out. So when you want take out the moisture from the wood chip or wood tissue, so we already studied that the water is going to start the evaporate when the temperature is crossed 100 degrees centigrade, isn't it? So below 100 degrees centigrade, the water is not going to release as a steam. It is not going to become an vapor. So then for the drying zone temperature, so we required 100 and above degrees centigrade. So that means 100 to 150 degrees centigrade place. Here what happened? Whatever is moisture is present in that wood chip, the wood log, that is going to taken out. Okay. Then the next is going to the pyrolysis. Okay. The slowly the red hotness is going to come into the picture here with partial limited air and oxygen, whatever it is the present there. Okay, slowly it is going to become the red hot. So by the time what happened, the temperature is 300 to 500 degrees centigrade is going to take place. Then the combustion is going to take place 900 to 1200 degrees centigrade. Complete combustion is going to occur. Even the lignin is going to become the combust. Then after that, it is going to reduction. That means the coal is going to formation, or maybe the hash is going to formation is going to occur at 700 to 800 degrees centigrade. So here what happened? The feed stack or the fuel is going to move from the up and going down like this, all the stages, then coming down to here. At the bottom side, hash will be collected, and here the ash will be deposited. But if the light ash particles will be there, something like that, because the gas also going to move. Just wait, I'll take the pen maybe. Yeah. Right. So here the gas is going to come. Whatever the gas is presented, slowly the gas here, and it will slowly it will coming like this, and it will move. This is the movement of the gas, right? Can you able to see whatever I am drawing here, sir?
Yes, sir. It's visible.
Yeah, thank you, sir. So the gas is going to comes like this because it is a sealed one. This is closed completely, so it will be deposit only in this place. That's it. But even here, it is goes up again. It will move up, but here it is a locking system. It is not going to mix here, and it is not going to mix in this place. So the gas will move like this, and this it is going to coming out. This will be coming out. Then mean this the gas temperature will be always having somewhere around 600 degrees centigrade, even 500 to 600 degrees temperature it will be there. So that gas having now lesser in the density because of the higher in the temperature of it. So it becomes very the lighter, and lighter in the density is slow. It is slowly it is going to move upwards without any problem. But it having certain kind of the heat. Okay, that heat will be utilizing. Okay, that heat is utilizing at this particular zones also. Okay, it will be getting heated. the cylinder, even this side also. Okay, it is a circular. You just keep in your mind, it is a circular. So okay, it will be get heated. I will draw a circle here. When you suppose you are looking from the top side, let us say this is the bigger cylinder. This is the bigger cylinder, and there is one more inside another cylinder. Okay, this is the reactor. This is the inner cylinder. Okay, example, this is the inner cylinder. This one is the inner cylinder. Okay, this is the inner cylinder. Okay, this is the cone shape, gradually reduction. Okay, so here the combustion and drying, everything will be there. At this, around this, what happened, the gas will be same. So here is outlet. Here it will be outlet. So whatever gas will be there here, the raw gas, raw biomass gas, which having 500, 600 degrees centigrade, that will come here, then it will be moving out. This is called raw gas. So it is not clear gas. It is not very clear gas. Okay, it is the gas having impurities, that we will call it as raw gas simply. Okay, even some the hash particles also it is going to flow, because sometimes we will see even the hash, it is in white color, right? So it have been very lighter in the density, because of this flow it is going to mix along with that gas and it will going to coming out. So this, because the feedstock from top and the gas is going out from the bottom, so this we will call it as downdraft gasifier. Okay, the same thing we are used in our place. And here, okay, when the feedstock is placed inside, and then we are going to get closed, we'll be sealing it. So whatever air or oxygen is present in this reactor, that will be utilized initially in order to ignite and to become little pyrolysis process. Okay, so after that, suppose if you are not going to supply air from the atmosphere, so immediately whatever the the red hotness will be there inside, that is going to cease. That means after some time you won't be anything, you won't get any gas. Then what happened, because once the limited air which is present inside the reactor is completed, then it is going to cease immediately. Then what happened, after a few minutes, you have to see on based on your own instrument, then you start sending air from the outside. It is not like that how much air you want to be there. The air is required very, very minimal. That is called controlled combustion. That means how much air which is required in order to sustain only red hotness, not a flame. It should not generate any flame inside the combustion. Only red hotness. Only red hotness. It is just like, okay, I'll tell you the red hotness means how looks like. Example, we know agarbatti, right? In houses, during the pujas and something, we will be igniting. Then after that, you will be seizing, right? The flame you will be seizing. Then you can able to see tip of that agarbatti. There is a red hotness, right? So whatever the fuel we are placed inside, it should become in a similar manner only. No flame. No flame. If flame will be there, what is going to happen? Suppose if the flame will be there, you are allowed a flame here to come, okay, instead of the red hotness. That is the case. What happened? Whatever gas which is present in that wood pieces, the gas will be generating, and immediately it is catching the fire. That means the production will be there and combustion also there. That means you won't get any gas outside. You won't get any gas outside. What you will be getting? Only emission you are going to come. So we don't. Our aim is not a flame. Our aim is it should not have any flame. It should have only red hotness. Only red hotness. Okay. So it will come like this. So that is the reason we will be sending air how much which is required. That is, this is normally is called stoichiometry ratio. Stoichiometry ratio. That means how much oxygen is really required, or how much air is really required for the combustion. Only that much we have to supply to the combustion chamber. That's it. Okay, so here I've shown what is going to happen in drying zone, pyrolysis zone, gasification zone, and the combustion zone. So what is going to happen in the drying zone? The heat will be there and the moisture is going to driven off. Whatever is the moisture is present, that wood tissue, that is going to take out. In the pyrolysis, what is going to happen? Biomass plus heat will be there. Biomass plus heat will be there. That is going to start slowly charcoal, oil, and the gas. Okay, how you are going to get the oil? If you say it, if you take a small stick, okay, wood stick, small one, and you ignite it, okay, you just try to see very closely after the flame on the stick, after the flame on the stick, here you can able to see some kind of the gum formation is going to come. Okay, that is called a tar. From there you will be getting oil. Okay, tar oil you will be getting. So that is the dangerous that you have to crack it up. That is going to start formation in pyrolysis. Then in the gasification zone, what is going to happen? Biomass plus limited oxygen. This one, okay. Here you will be getting the fuel gas. So fuel gas we are going to get. Then the combustion. So biomass plus stoichiometry of oxygen. That's what I'm telling is hot combustion products we are going to get. Then the reduction. So what are the applications for this? Yes, we can able to generate the electricity in the rural areas. A diesel engine can be operated on the dual fuel mode without any modifications. Okay, and we can use for the thermal applications. Yes, and the biomass processing we can have. Okay, we can make the processing whatever you want it. Then we can have the heat recovery. Because a lot of heat will be producing. Suppose your aim is that instead of wasting up that heat, you can collect it by maybe designing a heat exchangers. Before that, you're supposed to know what purpose you are going to use that heat exchanger. Okay, based on it, you how to design it. Then you recirculate the heat which is you are feeling as a waste, that will recirculate it towards the heat exchanger and send maybe the cold air. That air is going to become a warm up, and then you decide what purpose you want that warm air. So these are the applications. Okay, so biomass gasification means incomplete combustion. Okay, keep in your mind, biomass gasification means incomplete combustion of biomass in the reactor. The reactor also we will call, some books and some researcher will call it as a gasifier, and some people will call it as a reactor. So you can use any name whatever you want it. So the resulting in production of combustible gases consists of, we said it is an incomplete combustion. So what are the combustible gases which are going to present is carbon monoxide, hydrogen, and some traces of methane, and apart of the products like tar and dust. Sir, please mute, sir. Somebody is, if they have any kind of the doubt, please you can ask me. I'm happy to answer.
No doubt, sir. No doubt, sir. Okay, sir.
Yeah, because somebody is talking, that's I got the doubt. Yeah, fine. Thank you. So in the biomass gasification, that is an incomplete combustion, but what the combustible gases is consist is carbon monoxide, hydrogen, methane. Apart of this, there are tar and dust also will be present. Okay, so is here essentially the gasification of petroleum products for the power generation. We can able to generate the power by taking this gas, whatever the gas is generated in the reactor or the biomass gas, we can able to generate the power. Okay, so this process also can be utilized to produce the chemicals for various applications, right? With example, a low burn of environmental of GHG, okay, greenhouse gas. Then the gasification process by which to convert the biomass into thermal energy has the lower emission compared to other solid fuel combustion technologies. So the carbon which is stored in the biomass material as it grows is already part of the atmosphere. Biomass energy does not add a new carbon to the active carbon cycle, whereas the fossil fuels remove the carbon from the geological storage, that is from the underground, and it is simply depositing. Okay, so you can able to see here another chemistry for the biomass gasification. You can able to see here simply first whatever shown in the reactor, like the drying zone and the pyrolysis zone, combustion and the reduction. These are the chemical reactions which are going to take place. Okay, so when the drying zone, what happening, I said just now, the moisture content is going to taken out in the form of steam, H2O. In the pyrolysis, what happened, tar is going to formation, that is got the liquid like, and then CH4 is going to form, okay, methane. Then in the combustion, what happened, you will be getting carbon dioxide, then you will be getting hydrogen, H2O, water. Whereas in the reduction zone, carbon monoxide and hydrogen is going to come. That is required for us for the combustion point of view. Okay, so this you can able to see here small the combustion process for the biomass, especially for the wood, what I've taken here. Okay, this is the in y-axis is the temperature, and whereas in x-axis is the time. Okay, consider it. You can able to see this is the timeline of the time versus the temperature. You can able to see at the temperature from up to 100 degrees centigrade, the vaporization of the surface, whatever the wood tissue is there. Okay, suppose this is the wood tissue, assuming in that this top side of the layer, okay, having the it is going to make initially the vapor of these water surfaces. It is going to vaporize from 100 degrees centigrade up to 100 degrees centigrade. When it will go from 100 to 200 degrees centigrade, so the hemicellulose, I've said totally 3 different compositions, right? Cellulose, hemicellulose and the lignin. So here the hemicellulose decomposition is going to start. Okay, so it is releasing the combined water, and the glass transition of the lignin and hemicellulose, then it is going to release inner free water, what present inside of, assuming that this my pen is a wood, okay, wood tissue. So it is going to take out from the inside, okay, and then it will send it to the outer, and then it will go out. Then when it will go to 200 to near to 300 degrees centigrade, so thermal decomposition is going to occur, and it is going to start the release of the gas, and whatever the cellulose is present, it is going to become the softening. Okay. Then when it is goes to 300 degrees centigrade, yeah, so here what is going to happen, it's simply ignition is going to come into the picture. So, and the rapid exothermal reaction is going to take place, and increasing the gas release rate very fast, it is going to come, and the ignition of the wood surface is going to start, whatever the thing is there, the surface is going to start the igniting. Okay. Then when it goes to 400 plus degrees centigrade, 300 to 400, then combustion and the smoke formation is going to occur. Why? Because the gas is going to come out completely. When it then whatever thing is there, so slowly it is going to ignite, and it is going to start the smoke. So at the 400 degrees centigrade, it is going to take place, and it is going to stopping of the smoke, and drastically reduce the wood tissue weight, because the gases came out, the lignin, the cellulose and hemicellulose, whatever is the present, it is came out as a gas, so into the lighter, the weight will become lighter. Okay, so the tar formation and the gas release also still it will be there, that is going to come out, and flame is going to taken place for the outer surface, and the rapid exothermic reaction is going to happen place. When it is go above 500 degrees centigrade, so it is going to start the complete the surface combustion, and stopping the gas release and tar formation. Okay, but in my case it will vary. Okay, it will vary from the wood tissue to wood tissue. It is not the same. It is I've taken is the generalized in the optimistic level, but it will be vary. So when I did somewhere around the surface combustion and the gas stopping is occurred at 450 degrees centigrade, And whereas the outer shell of the wood, the combustion is taken place somewhere around even 600 degrees centigrade. It will be varied 600 and 700 degrees centigrade too. Yeah, so these are the typical volumetric composition of the biomass gas. So like carbon monoxide in this form, 20 to 22%, whereas hydrogen is 16 to 19%, and methane is 3 to 4, and sometimes it is 0. Even 2 or 0.3, depending on the wood tissues. The methane percentage will be even less. Okay, then carbon dioxide about 9 to 11, and nitrogen is 50 to 50. So that means more than or 50% is nitrogen will be presented in the wood tissue. Sir, somebody is talking. I'm getting some disturbance. Yeah, thank you.
Sir, no problem, sir. No problem, sir.
Yeah. So here, 50 to 54%. That is this nitrogen. If you take any wood tissue, 50 to higher percentage of the 50% of thing will be present in the nitrogen only in that wood tissues. So this nitrogen, the way it will go into the combustion, it won't take any reaction the way it is going to come out. Okay, suppose if you have the technology in order to capture this nitrogen, yes, we can make even the liquid nitrogen. That is another research area. So apart of these compositions, we are going to get the tar particles material. Okay, dust and tar that is going to form. So this is one of my line diagram, and this is my actual gasifier reactor in my center in the Osmania University. This is we designed for 32 kilowatt rating of it in order to run the gas turbine to generate the power. Okay, for that is the purpose we designed this, and we have started the running of it. Okay, and using. This is a line diagram. Okay, this is a line diagram. So this is my reactor. Is this inside one is called the reactor, and this is the outer shell. Okay, and whereas this is a air circulation pump. So the atmospheric air will be circulated to at this point at the center. Okay, there is a pipeline, air pipeline will be there, and during the combustion phase it will be giving, but there is a controlled volume will be there. How much we want to be, we are going to circulate, and all these are the thermocouples in order to measure the temperature, and of course the pressure gauge also we have placed in it up. So then this is the raw gas outlet. The raw gas is coming like this and entering into the cooler, kind of like heat exchanger. The water is going to sprinkle over here. The moment the water will be sprinkling, water jet, this temperature is around 700 degrees centigrade is entering. That means it is going to have even the hash particle. Okay, so then the water is sprinkle is occurring here. That the hash particles are going to absorb this water, then it is become higher in the density. It will be suspended in this ground. This is sealed with the water container. Okay, and then after that again this air, the gas will be circulated into the scrubbers. So there are 3 scrubbers we are placed it. Due to the centrifugal action, of course the water circulation is going to take place, and due to that centrifugal motion, the high-end particle, high-density particles are going to throw it away, and it will be deposited. There is no leakages here. Then after that, again we are cleaning in, sending to cyclone. So in the cyclone, the gas will coming like this, and it will goes in this fashion in the down and centrifugal, and then it will moves up. That means any higher density particles will be there, that will be deposited and suspended here, and the gas will go. Then after that, there are filters. So there are 3 different filters we have it to removing any impurities are there. Then after that, we have completed the storage tank. So in this container, whatever the gas is stored, the biomass gas, that is completely cleaned, and straight away we can use to run the engine, or maybe you can run the turbine straight away without any problem. So before letting into the engines, then what happened, we have a flare. A small burner is connected and we are ignited. We would like to see the what kind of the flame color. I'm going to show that video also to you. Okay, after this lecture is present completed. So then it is coupled with the generator and generated. So we generated about the 5 kilowatt power in my place. Okay. Yeah. So this is the same thing what I have explained here. Yes. Okay. These are the things of the cooler and the scrubber. This is called cooler, and these are the scrubber, and here you can able to see the cyclone. Okay, these are the filters. There are 4 filters, and the final one is called a storage tank. Here the mesh, a small fine mesh will be there inside, and the bottom side is sealed with the water container. Yeah, so this is the engine. Okay, single cylinder of engine we have it, and this is coupled with the generator, and then we have circulated the this biomass gas here. Initially, it is starting running purpose. We are used the diesel, and then that is the diesel is cut off, and this engine is run with only a biomass gasification in order to generate. This load is whatever is existing. My system is only that is the 5 kilowatt on the turbine. So these are the different type of the gasifiers will be there. You can use it whatever you want it. Okay, this is the one what I've explained previously is the downdraft gasifier, and apart of the downdraft gasifier, the one more is called the updraft gasifier. Here what happened in updraft is the feed stack is from again the top, whereas the gas, whatever the gas will be generated, it is going from the top only, not like unlike here in this fashion. Okay, here it is. So both will be there. Then the reason we will call it as a updraft. So here again the drying, pyrolysis, reduction, and combustion. In this case, what happened in the pyrolysis? Whatever tar is present or generating, right? The tar is slowly will be coming here and deposited at the bottom side. But whereas in this, whatever tar will be coming, it is going to straight away crack. So we are not found any tar formation even at the bottom level in this place. That is the advantage. So here a lot of tar will be going to present, and that is maybe going to cause some kind of effect in the heat transfer point of view. Okay, and other one is called the third level is called cross draft gasifier. Here again the same here. So here the combustion will be taking place only at the center point. Okay, so this entire thing is the drying zone. Okay, this is the combustion zone. This is the pyrolysis zone is going to happen. The entire place is the pyrolysis zone. So then the hash pit will be there. Here also tar will come, but it is not that much in effective. It is not that much in effective. Okay, so this is the sum of the history for the biomass gasification. Somebody said, right, it is not a old during my Mentimeter. That's absolutely true. It's not any new technology. It is an old technology only. So what is that? So the process producing gasification method has been used more than 180 years. Okay, so in the early time, the coal and peat were used in the power plants, initially developed to produce called the town gas, that is called coal gas, for the lighting and the cookings in 1800s, and this was replaced by the electricity and the natural gas. It was also used in blast furnaces, but the bigger role was played in the production of synthetic chemicals, where it has been used since 1920. So during the World War, especially in the World War II, the need of the fuel production by gasification is re-emerged due to the shortage of the petroleum and wood gas generators that are called gasogen or gasogen were used the power motor vehicles in the Europe by somewhere in 1945. There was the trucks and buses and agricultural machines were powered with by this gasification only. So it is estimated, there was around 90, okay, or 90 lakhs of vehicles running on the, producer gas, or we'll call it as biomass gas over the world. That is a small history, okay. Yeah. So this is the classification of the biomass resources. Fine. The technology is fine, but what are the biomass resources which are available? Okay, just you can see here, this is not a limited. Okay, so the biomass resources, like I've used 2 different categories called untrapped natural resource, and other one is the plantation. What is untrapped natural resource? Like agricultural, all agricultural things, whatever it is there, including your rice husk and wheat husk or anything, right? Okay, then livestock, forestry, and fishery groups. So in that agriculture, you will be getting rice husk, rice husk and rice straw we can use, and wheat straw we can use, vegetable residues you can use as a fuel, etc. There are many things which will be coming. whatever you are using as energy crafts, we can use straight away. Then livestock like animal waste, we can use it. And forestry, okay, forest residues and thinned woods and processed waste and sawdust, we can use it as a fuel. And fisheries, so processing of the waste and as well as dead fish, we can use it like many. And other waste groups is like in industry. In industry waste, what we have: sewage, shifting sludge, and organic processing waste, etc. And household garbage and human waste can be used it. And similarly for the plantations, like a continental area and the water area. In continental area, you have a grain and plant, vegetable, fat, oil, and etc. And whereas in water area, like algae and photosynthesis bacteria and etc. So you just name it, anything, okay? We can use it as biomass resources. That's the reason I'm telling it's not required to cut the trees. It is not required to go for the deforestation. You just collect the energy crop from the farmers after the crop is completed and store it and process it, and you can use it for the gasification straight away. Suppose you have a lot of wheat cultivation, a lot of rice cultivation will be there. Suppose after the shell is taking out, okay, the rice you are used to eating, and whereas the rice husk, suppose you are not utilizing for any other purpose, yes, you can collect it and store it. We can use it as a resource. Similarly for wheat also. Even not only that, even a straw, the rice straw, okay, or the wheat straw, we can use it straight away. Or if you take the cotton, okay, once you are taken out the cotton, then simply you will be firing it out, and you are just entire thing, you are smashing it, right? Instead of that, you just collect it and store it. We can use it. Even maize, corn, you can use it straight away. Suppose when you have a corn, you are taking about the corn, right? Then you are taking out all those grains, and the rest of thing, instead of throwing it away, we can use it as a resource. A part of the cotton stalk and cotton leaf, corn stalk and corn leaves, you can use even that butta, matka butta, you will call it as, right? We can use it as even the biomass fuel. Like there are many things, okay, many things we can use it on. Yeah, so as India has a large amount of the biomass, so there is a high biomass potential in India. Okay, these are the something you can able to see in India. Agricultural potential, agro potential is this much. If you are able to collect complete agricultural potential, we can able to produce this much power, megawatts electrical. And livestock, if you collect this much, you can. Fruits, you can. Waste fruits, okay, I'm not talking about the fruits which you are going to eat, the one which is the waste. And the vegetable wastes, you can collect it. And then the industrial waste, you can. So we can able to produce this much power. Just imagine. Okay, so how looks like a crop and shape of the biomass resources. Okay, if somebody is not seeing, yes, I am going to show this. You can have, this is a rice, okay, rice paddy, and this is the rice. And if you, what we are going to eat, we are taking out this a small, the seed, the shell you are taking out, the inside one you are eating. Okay, so what I am telling, you can use this, the shell as a fuel. This one, the straw, also you can use it as a fuel. If you are not using for any other purpose, you are just, suppose you are dumping just like that, then we can use it. Similarly, the corn waste, okay, the corn waste normally you will throw it away, right, after taking about the grains, but we can use it straight away. Then palm, somebody's have the palm forest and from crafting. So some palm, suppose after things, suppose you may not say that, right, because it's not good to use for the palm oil and all that, you just simply throw it away. Instead of that, we can collect and use it up. Similarly, tur, right? So you are taking about only the inside of the seeds, and the rest of thing you will be treating as a waste. Yes, we can use it. These are the few. Okay. Similarly, soya stubble. Okay. Then sugar cane. Yeah, you can use the sugar cane, fine, for a purpose. Suppose you are feeling that once you are extracted the juice and all the everything you are dumping just like that. No, we can use it as. Then citrus pellets, we can use it. Then the cotton, that's what I said. Okay, these are the few. Okay, sunflower, wheat straw, corn straw, okay, vegetable residues, and the bagasse, okay, coconut. You have a coconut, right? You can collect the coconut, right? Any day, any time, right? You will offering for your prayer and the pujas and something. You will breaking out and you are taking the inside the coconuts. Then the shell you are just throwing it away. That can we can take out. Similarly, the groundnuts, right? The groundnut crop, you are taking it out and you are separating it from the roots, and then you are taking out the shell and the grains you are using, but the rest of the shell you throw it away. So that we can use it as a fuel by making the briquette. These are the some of the briquettes for the groundnut shell, and these are the coconuts briquettes. So these briquettes we can use direct as a biomass fuel in the reactor settle. Okay, so these are the different type fields and shapes similarly of the biomass, like a garbage, corn, alcohol fuel, landfill gas, and something. There are many. Okay, these are the wood chips, what I said. This is the sawdust. It looks like when you go in a furniture industries, we can see a lot of sawdust over there. Okay, so through sawdust, we can able to make kind of the briquettes. Okay, sawdust, the like this. Yeah, this is something we did, made a pellets by taking jawar straws. There is a lot of jawar they made in that by the time when I was there in China. So that is the machine making of the pellets. So these are the pellets you can able to see pellet making machine it is. Just you feed inside the straw, that's it. So you will be getting a pellet is out. Okay, so these are the pellets you can see. Okay, these are the some of the briquettes which will be made with another machine, and this is a reactor for the combustion purpose which we are placed inside. Okay, so these are the fuel like agriculture. Just now I said this any furniture like construction, demolition of wood, yard trimming, and non-recyclable organic whatever it will be there. You can take pits, chalk, shells, and burning screws or the forest slash. So you can send for the combustion straight away to the power plant, and we can able to generate the electricity. Okay, so here what the thing, the most important thing which is we required here, how should I select a biomass fuel for the combustion, or this is good for me in order to generate. The only thing you suppose keep in your mind, this term is called bulk density. So bulk density is the property of the powder and granules. Okay, any biomass issue. So what it is defined as the mass of many particles of the material divided by the total volume. Okay. So wide range of biomasses in the form of wood or agro residues can be used in the gasifier. Any biomass that has a density of more than 250 kgs per cubic meters can be used for gasification. This point you have to remember. Any species bulk density 250 kgs per cubic meter and higher is recommended for the gasification. So here you can see a few. Okay, sawdust, loose sawdust, it will be like this 177. When you make sawdust as a briquette, it becomes 555. So then what happened? Whatever the thing which will be have the lesser of the 250, you make the pellets or the briquette, then we can able to reach 250 and above. Then we can recommend it straight up. Okay. Yeah. Similarly, another one you can able to see a sawdust blocks and soft blocks, like these are the woods, and this is a loose straw will be having only 80 bulk density kg per meter cube. But when you make it as a bale, then you will be getting 320. See, just an interesting point of view. Okay, so corn crop, if having a lesser of 11 percentage of the moisture which will be present, then it having 304 like this. Okay. Yeah, so this is a state-wise biomass potential in India. Oh, sorry, the installed capacity I'm going to show. from 31st of, as on 31st March 2019, have taken from MNRE site. So here you can able to see some of the potentials here I mentioned, okay, with this particular colors of, you can see Andhra Pradesh, Telangana, Madhya Pradesh, Chhattisgarh, and these places. Okay, here it is 0 mostly. Okay, Jammu, Kashmir places. Yeah, you can see here the state-wise and total installed capacity on the biomass, that is maybe a grid connected bio or biomass biogas or power plants biogas. Okay, this is the total capacity which is installed in this particular state. Look at in the Andhra Pradesh, so 378 megawatt is there, which is there. Okay, so the highest is in the Maharashtra, 2499. Okay, then Karnataka 17, 1783, it will be there. Then Uttar Pradesh is 1957. So Maharashtra, Uttar Pradesh, and the Karnataka is in very in a higher, and the rest of things will be in 100. Then Tamil Nadu also is good somewhere, 9,000 plus 900 and plus it will be there. So whereas in Andhra Pradesh 378, maybe in okay, Telangana is only just 158. Okay, so totally this much is there, 9,103.50 megawatt capacity is installed as of 31st March 2019. Okay, yeah. So here we can see this is taken from MNRE, Minister of New and Renewable Energy, has set the national target to achieve 10 gigawatt of installed biomass power by 2022. So their aim is 10 gigawatt. Okay, so India has the potential about the 18 gigawatt of the energy from the biomass, but the targeted is 10 gigawatt by the 2022. So currently about 32% of the total primary energy used in India is derived from biomass. Okay, so here more than 70% of the country population depends upon the biomass for its energy need. So suppose if you go to the remote places or even the villages, so they are going to make their food by using the biomass only, right? So they will take the small, the wood chips or maybe wood sticks or something, right? So they will be igniting and then they are going to prepare their daily need food. So that is about even 70%, even little more higher. So India has close to 5 plus gigawatt capacity biomass powered plants. Okay, and then 83% are grid connected in this, while the remaining 17% are off grid out of 5 plus grid watt. So the half grid plants are divided between the cogeneration plant that do not utilize the biomass gasifier for rural application, and biomass gasifier for thermal application in industry. You can have around 70 cogeneration projects under the implementation with the surplus capacity about 800 megawatt. So there are the leading states for the biomass projects is Maharashtra, Uttar Pradesh, and Karnataka. But somewhere the favorably consideration opportunities in the Punjab and Bihar. That is about in India. So you can able to see this, the biogas plant market growth rate by the region 2020 to 2025. So this is in India, Asia, completely Asia. You can able to see will be the higher, and this is in the medium, America, North America, South America, and maybe in Europe and Russia will be in the medium point. But whereas in African continent and the Middle East, I have the low at that places. Okay, yeah. So this is here normally the Europe is the dominating the biogas plant market. The maximum value of the biogas production during 18 is around 45% of the total biogas was produced in the world. And during 18, the region is 17,780 scale digester plants in approximately installed in around 11 gigawatt. So Germany is a dominant country with the highest number of biogas plant, and followed by Italy, France, Switzerland, and UK. Okay. So these are the things we are supposed to keep in our mind. Yeah, so understand the gasification process with local fuels for power generation at remote places. Suppose because regular electricity may not be possible in order to take in nook of the corner in the country. So the remote places may be having the mountains and hill stations and the valleys and other things will be there. But plenty of the biomass resources is available at their end. So that is the place we can target it, setting up the plant like maybe 1,000 houses or 100 houses. Yes, we can make the power generation and as well as for the cooking gas. So it was expressed that industries using the biomass fuel establish an optimum operational parameters using the gasifiers and study the various parametric sensitivity on the biomass fuel, such as effect of the fuel processing versus preheating of the air and effect of the surface moisture of biomass, both the calorific value and loading parameter. Normally, calorific value is very less in this. So gasification technologies offer a high potential as they can produce the energy and the chemical vectors from the variety of the biomass materials. So these vectors can be used in the numerous applications directly or after further processing and upgrading can be either in the gaseous state or the liquid state depending on the process the application. Okay, so here when we are taking a different kind of the biomass species, you can able to have the proper mixing of the proportions for the different biomass fuel that is required to ensure the better gasification and the better combustion of the biomass fuel. You can mix it, not necessary to use only one kind of the biomass fuel. Okay, you can mix it together. And the area, the present and dilemma that the gasification community, since the gas turbine manufacturers do not wish to develop the more robust engine, so that could operate with some contamination of the biomass gas, as the market still consider the very small, because the gas turbines are there using for aircrafts and all. But if you take that aircraft gas turbine and sending this, because it is very difficulty, because still maybe minor particles of contamination if there, then your gas turbine will be giving you a problem. So the gas turbine developer, they have to think in of it, even not only for that natural gas and all air, but they can able to make they are thinking about even to make the gas turbine in order to run with biomass gas. I think the days are going to come, maybe very nearer. So the main task for the gasification industry to deliver the clean gas to the combustion chamber with the gas turbine. That is the main thing. Okay, because compressor, combustion chamber, and turbine all together only a small, right? This much unit. That is a tricky one. So it's need to be developed the automated briquettes making machine with lower power consumption for any kind of the biomass resource. Now, because wood, suppose I am taking the cotton stalks or something, right? Jawar stalk and other things, I can use it. But I want to use a another like a coconut shell, okay, or the groundnut shell. So I cannot use this machine. I have to use another machine in order to make the briquette. So instead of that, we have to make the generalized machine so that you can use any kind of the biomass resources in order to make the briquettes or pellets. Only you need to select the operation. That is the another challenge. It's a good potential too. Yeah, yeah. So thank you for happy listening. Here I'll show one video, sir. Okay, I'll show one video. Then after come back. Is it okay, sir?
Okay, sir.
Yeah. Just I'm stopping this share. Then I'll share my video. Yeah. There are two videos are there. Just tell me, sir, are you able to see this?
Yeah, yes.
Sir, can you able to see this video?
Not played, sir.
No, no, no. I stopped it. Just I want to take the confirmation. The flame.
Your drive is showing.
No, no, no. The video I have started. Just now I stopped it. I am going to restart it.
You share it, sir.
Yeah.
Your video is not shared.
So kindly open that VLC player, okay, so that we will be able to see. Now your main tab is open. NS online guest lecture, the tab is open.
Oh, okay. I have to make it into VLC straight away. Then okay.
Yes, kindly open it, and then only we'll be able to see.
Acha, fine. VLC player. Okay.
You can double click on that. That will be directly.
Yeah. Yeah, I have double clicked, but again now I. Yeah. Yeah. Here the media. Open file. Can you able to see, sir, now?
Yes, sir. It is visible.
Yeah, that is, this is actually my gas turbine here. The gas turbine combustor, we have designed it, and this is the gas which we generated in our plant, and we are testing this particular, the flame. So normally in the gas turbine combustion, this kind of flame is required inside in order to drive the turbine, There is no smoke here at any point of the time. This red hotness is essentially is the required. Yeah, I'll show another video.
So in this, what is the proportion, gas proportion you guys used over there?
No, no, no. It's not the almost 1:1. Air and gas.
Okay. Gas is methane.
No. This is a biomass gas.
Biomass gas. Okay.
Biomass gas only, not methane anything. Methane will be there in that very, very less. But normally we required, suppose if we have the higher methane percentage, what is going to happen? It is going to bombarding. And the combustion is bombarding is required.
Okay.
Yeah. So I'm showing another one. This is the flame. Can you able to see this flame now?
Yes, sir. It is visible.
Yeah. So this is the flame. Before letting out into the our turbine or maybe our engine, the flame will be testing like this, whether it should be in the red or is getting any smoke or is it there any bluish color. Then that will be not recommended. It should be like this only. Then yes, so we can recommend straight away to run. Suppose something is a contamination, something will be presented, the flame will be not like in this color. So you cannot see anything, even the bluish also, right here.
Yes, sir. But can you tell me which type of gasification process you used, which type of reactor you used?
Yeah, I've shown right my figure. You can able to see in my video, even the reactor too.
Okay.
Here is the reactor. This is the reactor. This is the
Yes, sir,
reactor.
fine.
The gas will be coming out from here. Okay. Yeah, the people are there. Some of my research scholars have taken the help from them, and in order to take the manual readings and all, we have even the data acquisition system at the same time also, apart of the curiosity. This is the reactor.
Yes, sir. Nice, sir. It is
top,
nice.
Yeah, top side is the place which we are going to insert the fuel, and these are the initially for sending the ignition inside, and then we'll be closing off it. And this is the cooler, and these are the scrubbers is we using. I think here the storage container can able to, this is the storage container, and these are the filters again, some more filters, because we want without any kind of the contamination in it. Maybe I think electricity produced lights you can see, maybe it might be there somewhere.
Sir, what would be the cost of this complete setup? Can you explain, please?
Oh, it is a very higher, man. that we developed in the design by design. Reactor is one side and then other one. This is the existed one. The existed system we are used already. Initially we brought this later, but the reactor and everything we designed about the it is somewhere around 14 lakh. The reactor cost that we designed and we developed and we gave for our people for the manufacturing. Local people they made based on our drawings. Then we have tested. These are all my things. So I can able to take the readings from there, the pressure, the temperatures in the various places, and flow rates, everything we can able to record it. This is the gas turbine. Oh, sorry, it is gone that way. There is another light. I think it be here, or maybe we will see quickly. The light will come. I think it may be there in the next slide. Yeah, maybe in this here. Second, or maybe here. Yeah, this one. Here, yeah, this is about only somewhere some seconds only. You can see the light flash will come and go. So they forgot to capture by the time in this video or the last moment. Yeah. This is the light.
Flash point and fire point over here.
Yeah, it's a total 5,000 watts.
Okay.
That is a normal, right? Your halogen lamp. I think you know halogen.
Yes, sir. Yes, sir. Sir, can you tell me in the reactor what type of raw material you put in that particular?
Sorry.
What type of raw material you use for
wood? We have 3 different types woods we have tested. This is called normally the subable wood, right? Which is used very long, right? So they were collected with the dried, they were just throwing it away. So we collected it and then we made according to our own sizes, whatever size do we require. We have the cutter, the wood cutter, we had it, and then we made the cutting from ourselves straight away. And then that is feeded about 32 kilowatt. The size is 32 kilowatt. My plant capacity, because we have the 32 kilowatt the gasifier, that what we designed. So because our aim is to run the turbine, our aim is to run the gas turbine and as well as the diesel engine without any modification. So the diesel engine is we have operated, then we was saved around 80% of the diesel for operating about 2 hours for 5,000 kilowatt. So we measured initially, we run the 2 hours of the diesel engine on the diesel. Then we have noted out how much diesel gets consumed. Then we have operated by connecting this our biomass gas to it. Then again we operated same number of hours without any compromise, and there is no choke. Ultimately, it is completely clean. We thought that engine may be going to choke because of if any tar is present in the gases, but that is not happened anywhere. Even as in today, it is going to run without any problem. So then we estimated how much diesel we have saved. So for the 2 hours of running continuously, so we have told almost 80% diesel we have saved it. So just imagine, right? If this is there, we can set up even a plant in the remote places wherever we want, and then you can able to send the power supply to the remote places. Okay, where maybe a hamlet is there, right? Having maybe 100 houses, or maybe 100 people, or maybe 1,000 people will be living in that place. Those will not have the regular current electricity, so we can. And otherwise, suppose instead of using their the wood sticks for the daily need for the cooking purpose, suppose they are not having LPG supply in their places, so we can use the biomass plant setup. We can make it up, and then one big container is need to be erection, and then that will get sealed with the water at the bottom side, and operate about a few hours of the plant in order to generate the gas. So whatever gas is generated, that need to be filtered and clean it up, and then send it back to the container for the storage point of view. From there, you connect a main pipeline, then go to all the houses. If 100 houses are there, all 100 houses you can get connected. Okay, then you can make a meter in each and every house. Because they're supposed to know that how much gas they are consumed. Based on that, you can get the bill. So you can employ some of the people for even operating the plant, and as well as taking the what do you call the reading, meter reading. So that, like, okay, the way you are using the LPC, the cylinder is coming to your house and you are using. But whereas the big malls and big apartments and all, they're making as a centralized. Same concept we can apply for the, suppose the people have the 100. So then is happily they need not take for any wood, wood sticks and all things like firewood and making. So straight away they can use this gas and they can survive it. So they can get
Sir,
the power. Yeah.
Sir, instead of using a wood, okay, can we go for a plastic, because wood is, again, we can use it for some byproducts. Instead of that,
You
if you go
cannot
with
use
some
some wood
plastics.
is as a waste. See, plastic is the different.
Okay.
Plastic is the different. You cannot require for this type of gas fire plastic. You cannot use, but you can use plastic for another purpose.
Sir, continue, sir.
Sir, it is over now already. I finished it. If any question, just I am asking. Somebody is just I am addressing them.
Sir, Madhyana means sir, program 2 virtual.
So you can use wood, waste wood. You can use sawdust. Okay. You can use cotton waste. You can use tur waste. Okay. You can use corn, and you can use the forest residues. Okay. You can use anything, any vegetables related things. You can use it. Any dried. Straight away we can make the briquettes and something which is not possible to use it directly. Because why? Because in the when it is going to the combustion chamber, there is a bridging gap is required. So when I'm making the briquettes, right? So briquette 1 and briquette 2, the pieces are done. There will be a gap that is for air circulation. It is required. That should not be closed. That's the reason we are going to make a round shell, or maybe chip, or maybe the briquette. Suppose if you are taking the sawdust and directly you are pouring inside the reactor, the bridging gap is very, very small. Then what happened? Whatever the small, species of sawdust will be there, it is a very, very little amount of the gas will be present. Suppose that is ignite, immediately it is going to become, say, hash. So there won't be enough air circulation inside. That is the reason we are going to make the pellets or the briquette in order to increase their even the bulk density. Then it is very easy to generate the gas.
Fine, sir. Thank you.
Yeah. You should not use anything directly powder into the reactor. Make the briquettes or the pellets. Yeah.
Fine, sir. Thank you. Thank you so much, sir.
So
Thank you.
Thank you, sir. Thank you for this opportunity for the Rajiv Gandhi Memorial College of Engineering and Technology, and especially the head of the department, and as well as the coordinator, Dr. Tirupati Reddy, Dr. Siddha Reddy, and also thanks to the entire college management. I hope that participants may be taken something from me. I hope I understood. I think they may set aside in the future towards the biomass. It's a big emerging challenge. There are many things there to do in R&D point of view, even your research point of view, doctoral work, something. Yes, there are many things you can able to do in it. Yeah,
Thank you, sir, for accepting our invitation to give an expert talk on the biomass energy. So participants also has given a good feedback, and we have an excellent session also from from you.
Thank you, sir.
So once again, we will contact you, sir, for the phase 1.
Yeah.
Right, sir.
Yeah.
So we expect the another presentation by you.
Yeah.
February or something. Actually,
Okay.
phase 1 not organized as per the plan. So
But okay. Okay, it's good, sir.
Once again, we will contact you for the phase 1 also.
Sir.
So please give one more session on phase 1 in the phase 1.
Yes, sir.
So thank you, sir, once again.
Yeah, thank you, sir. Thank you.
Right, sir.
For the opportunity. Thank you, sir.
Thank
With
you, sir.
interacting with all you people through even in online mode, it's a very good to see all you people. Thank you, sir.
Thank you.
Yeah. So shall I leave, sir?
Yeah, I'll leave, sir.
Yeah.
So dear participants, so with this morning session ends. In the afternoon session, so we'll have a virtual visit of soya milk plant, which is established in the RGM section, Nandyal. So there, the Professor V. Sivareddy will explain how to produce the soya milk and also how to make the what we call soya paneer. So that will take maybe half an hour to 1 hour. After that, from 3 to 5, so there is a session by Dr. Panikumar, scientist F from National Institute of Ocean Technology, Chennai. So all of you join in the afternoon session at 2 p.m. So thank you, sir, for everyone.